Thank you very much for inviting me. It's wonderful to be here at Wharton and UPenn, my first time here. So this is a paper with Jacob Dominski, who is my pre-doc, who will be on the doctoral market. We'll be applying later this fall. He's terrific. Please do consider him. So the motivation for this is we all care about what the impact of AI on labor is. So many of us have been examining this question, and it's been hard, right? It's hard because there's data issue. It's hard to measure AI's adoption in organizations. So what what's thought is, we really should know what the near real-time effect of AI in the labor market is to get a better sense of policy impacts, strategizing, how households should respond. Why don't we use CPS, the Current Population Survey, which is a data set where we monthly get information about unemployment rates and certain aspects of the labor market. And let's link that to AI exposure, which has been done, spearheaded that by Daniel Rock over there, right? And the idea was AI is advancing so rapidly. We've seen that in this morning, we should consider that change as well. So let's think of a framework where we map the progression of AI's capability. We can map that to certain time periods. Think of those as stages. If you're more comfortable, what you're thinking about is a panel data, longitudinal data, and let's map that to CPS. That's basically it. It's more of an investigative empirical analysis. The goal of this project is to provide this real-time analysis, of course, published paper, but I'm an economist in a public policy school, and one of the things that I think are important is to provide information to the public where they can actually go see, click on occupations, click on charts to see what's happening in occupations. So that's what I'm trying to do. I won't go over in the interest of time. Is someone keeping time? Oh, there's time over there. Okay. So yes, many of us have done this, trying to contribute in this one small angle, but ultimately also provide meaningful information to the public. All right. So what we do is basically that. I'm going to do prompt engineering. I'm going to tell the model, these are different stages of AI development for different periods of time. Go through ONET, read through each task, and assess what percentage of each task you think you can actually perform. So it's slightly different from Daniel Rock's paper where they ask about, how much in terms of time reduction you can actually think about, but I'm actually directly asking about their capabilities. And then I ask, I did this with ChatGPT 4.0, Claude 3.5 Sonnet. I did it with Llama 3.0b, and do correlations, see how robust they are, different models, different prompts, etc. In the interest of time, I'll just show you. It's focused on ChatGPT results. In terms of analysis framework, it's a pretty short panel if you think about AI. So rather than doing a monthly or yearly first difference with, fixed effects, doesn't really work well. So the idea was if you go back and think about say Asimogan and Restrepo or the trade literature, we often use long differences, first differences, to try to get the impact of technology on the labor market. So I'm going to employ a first difference framework. It's not long, right? About a 2-year period, but actually see some result. Now, if you know the literature has primarily focused on productivity, and we do find a lot of productivity benefits. The literature on labor has been much less clear. Some good results using Danish data find no real impact on the labor market. It's in general, AI is I think good. It's not really hurting the labor market. We don't have direct evidence. I believe we're the first, at least, to find real-time negative consequences that are emerging. So I'll show some of that here. Key finding is, I think this is, a previous version of the slide. There's actually another slide that was up. I'll just use this one. We just checked right before, but this is ultimately the key finding is AI exposure decreases total employment, increases unemployment rate, and another nuanced finding is that it's reducing hours worked in their primary job. We're seeing people taking up secondary jobs, part-time jobs. So it's something we hadn't thought before, but as people are more exposed to AI in certain occupations, they're picking up additional income sources. In terms of, we all talk about exposure is not, we don't know what exposure is, right? It could be substitution, it could be complementarity. I'm just providing descriptives. But one way to think about this is let's go back to our old task literature that Tor and Sumoglu examined. We have these measures of non-routine cognitive tasks, non-routine manual tasks, routine manual tasks. Using those as proxy, basically identifiers, we can sort of parse out, okay, as exposure increases, where do we see less substitution or even more complementarity? So that's what we're going to do as well. I won't go over ONET. The occupational exposure score is, like I mentioned, I'm going to use prompt engineering. Okay, I'm not sure if you can actually see this, but it's basically stage 1 is traditional machine learning. Stage 2 is when ChatGPT was released, early stage large language models. Stage 3 is multimodal generative AI when we're sort of using ChatGPT as a benchmark. When we see multimodality, language to image, image to text, video become pretty much established. Stage 4 and stage 5 is sort of forward-looking. Stage 4 is it's very recent, advanced reasoning models, the O models that we're seeing nowadays. Agentic models, we're at the very early stages, but I'm just assuming that suppose we have an agentic AI that's pretty widely incorporated, what does that actually look like? So these are some task descriptions that are used in the prompt, and I'm asking basically go over all the tasks, and then create measures, aggregate at the occupation level. And this is sort of what it looks like. And this is, it's a bit hard to see. Stage 1 is about, if we average exposure across occupations, about a little over 30% of all tasks are exposed or have capabilities. Stage 2 is where ChatGPT. Stage 3 is multimodal. And you can see the timelines I'm mapping here as well. Stage 4 and 5 is sort of forward-looking, and I won't be using that in this analysis. The key is the change in these measures. The change is between this stage and this stage that I'll be focusing on. And if you see here, we see a lot of changes still, in writers and authors at the top, but also more broadcast, graphics, technical, and these type of occupations that are emerging as well. And then the least exposed are the more physical ones that you can examine. The trend is, this has changed, but if you look at exposure measures previously, it looks somewhat similar. Those exposure measures tend to peak around here and then decline. But this is change, and we're seeing that, yes, it sort of peaks around 100K income. That's where we see most exposure happening between multimodality and compared to ChatGPT, machine learning. Okay, I'm going to skip that. In terms of if you just plot that across all occupations by the share of employment in different fields, it's somewhat bimodal. The bigger changes are happening more in the areas where we have office, admin, scientific. The left side is where we see least amount of change that are often service, transportation, and manual type of occupations. Again, these are all changes. So what's happening in real time, this is the framework I'll be using. About 5 minutes. First difference framework, where the tricky, I'll describe the timing here, is these are the time periods, 6-month periods that we focus on, right? And the nice thing about CPS is just last month, we have data up until March 2025. So group this period together, take the average, and group this period 2 years ago together, take the average, and those two will be our key outcome that we'll initially focus on. In terms of exposure, what we're going to focus on is S1 and S3, stage 3 minus stage 1. So the first difference in framework would be the outcome is between P4 and P2, recently and 2 years ago, and the change in capabilities will focus on multimodality versus pre-machine learning. Okay. So why is this important? It's hard to claim causality, but when I'm saying that we're getting a bit closer to causality, if we're able to do this at an occupation level, using first differencing, while controlling for factors that we think will be very relevant at the occupation level, which is, I think, like the key concern, I think, here is like, oh, what COVID or remote work. But probably those can be captured to these 5 task indices like automation, non-routine manual, non-routine cognitive, routine analytic. So we're going to try to add more variables that is actually measures of COVID prevalence or remote work, but we're trying to control for that. So with that, about 5 minutes, and I'll try to wrap up. Excuse me, it's 5 minutes including Q&A? Okay, all right. So what do we find? This is the result visually. This is the first difference regression, residualized, netting out all the uncontrolled variables. There is a significant negative slope in terms of total employment, significant positive slope in terms of unemployment. So there is a negative consequence that we're actually seeing in the real data. Again, a bit decline in hours worked and a slight increase in hours worked in the other jobs as well. Okay, so some people are picking up other jobs. Those we're seeing as the change in AI exposure increases over time. Full-time share is also decreasing as well. So that's sort of the key result. Maybe just one more thing that I'll highlight is, I know it's a bit hard to see here. There's this coefficient that's positive, and what this is saying is that if we look into potential complementarity, if we actually focus on occupations that have a very high share of non-routine manual physical occupations, in those occupations, when AI exposure is increasing, their employment is actually increasing. So there is actually, in some aspects, complementarity that's emerging in that domain. We see more people staying in their primary job as well. So that's basically it. Questions?
Hi, how do you think about pre-existing trends? For example, COVID reduced certain jobs temporarily, and then after that it recovered.
Yeah, that's a very challenging, I think most important thing here, right? And so that's why we focus. We're several things. We try to go a bit earlier because we have the data, but we ultimately decided not to, and really focus on 2022 being the point. And ultimately, we do want to capture. We're trying to get data on COVID cases by occupation. We're trying to put that in, but hopefully for now, we're just using these different task indices to try to capture the different characteristics of occupations. And if you had any suggestions on IV, I'd love that. Yes.
Yeah, it's really fascinating work. I missed the part where you had the average exposure by different stages. Can you state again how you got that? Were you aggregating tasks under those different stages?
So basically, the prompt is saying, okay, stage 1, stage 2, stage 3, stage 4, stage 5 is like this. It's the technology, and then I go through task and rank the exposure for this task at stage 1, stage 2, stage 3, stage 4, stage 5. So I have all those tasks.
And that's from the universe of ONET tasks.
That's right, and then the aggregate.
Got it.
Yeah.
Oh, go ahead.
Yeah, sure. Thank you very much. Thank you for the presentation. I think there were other AI exposure indices that were developed before. I'm curious how you validated yours compared to those.
Yeah, so we try to validate with the very early version of this paper. We actually use something pretty much in line with Daniel Rock's measure. So they're very highly correlated. So that's one thing to do, like in terms of mapping with, say, the web measure, like uses patent data, or the Felton measure that uses sort of technological advances. There's several out there which we will do, but the thing is, it's hard to get at changes with those measures, right? So it's hard to get patent changes over 2 years or 3 years. But it is something at the level that we can do.
I've just got a question about how you used the LLMs in this. How did you validate their exposure? Did you just get it to run once, or did you get them to run like multiple times and then take averages? And how did you compare the GPT to the Claude scores?
That's right. So I don't have these correlations here. I do run those multiple times, and it's expensive. So at this point, I realize I need to go to open source models, and that's something. But they do correlate very highly. I have a set of results that just focus on Claude, and they're pretty much similar. Frank?
Just a question on the last result you mentioned in the prior page. When are they complements? And when your key findings all say they're substitutes?
Yeah, I know it's a bit hard to hear, but here what you have here is there's a dummy variable identifying occupations that at the highest quartile of non-routine manual physical occupations. And in those occupations, as AI exposure increases, there seems to be complementarity.
Thank you.
So building on that, why do you think that is true? Why is that top quartile of non-routine manual physical jobs benefiting from AI?
So first of all, I think those tasks can't be automated with AI. And maybe, so think about, so I do some work on welders. So that, okay, AI can't replace welders. But maybe they're able to use those in technology because of multimodality, that they can identify good welds, bad welds, quality control a bit better than before. Maybe that's resulting, this is all speculative, some aspects of productivity gain at the firm. That's my best hunch.
Thank you very much.